Hello, this is Mr. Stansbury. I'm going to take you through the notes on loans. At the end of this, you should be able to say, I can find monthly repayments, interest charged, and outstanding balances of loans. Okay, so first thing, amortization. This is the process of repaying a loan with a series of regular payments. Interest is calculated on the reducing balance of the loan, so the interest reduces as each payment is made. It's basically an amortization table. You'll see that like whenever you're doing like a car loan usually, and certainly when you see a like a house loan. Okay. Anyway, with that, example one, Amare takes out a personal loan of $23,400 to buy 5,000 Kevin clocks. He gets a 5-year loan at 6% interest. Calculate the monthly repayments, the total repayment, and the interest charged. Okay, so the monthly repayments. So we're going to use this table down here because this is a personal loan. That's kind of the key word that I look for. As soon as I see personal loan, it's like, oh, that's where I got to use my little table thing here. So what we want to do here is we want to look at let's do this. This number here really should be 23. Let's just make this 23,000. Okay, so that should be just 23,000, like so. That makes this doable. And then what we want to do is we want to find out the total amount of money, actually in thousands. Here's the big key thing that a lot of people miss is this is table of monthly repayments per 1,000 borrowed. So if they borrowed 23,000, 23 is the number that we're going to use to multiply with. So we're going to take 23, because that's the number of thousands, times, and we are at a 5-year loan at 6% interest. So here's our 6% interest. So we're going to use this column here. And then we need loan term in years. So here's the 5. So then it's where these two, where this row and this other column, where they meet up, which is the 19.3328. So 23 times 19.3328 is going to be the monthly payments, repayments. Okay, so basically what this means, so you can understand what's going on, if I were to borrow $1,000, I'd have to pay back $19.33 per month. Okay? Okay. Okay, so we bust out our calculator here. 23 times 19.3328. And then we just go round this up to the nearest penny. So 444.65. So we're going to say, actually, I think we just go up to the next penny. Let me double check on that. Yes, we do. We go up to the next penny. So it's 654. So we're going to go to 66. So 444.66, $444.66 per month. Okay. So now to calculate the total repayment, we take our monthly payment, $444.66, and we multiply that by the number of months to figure out what the total repayment is. So if we are at 5 years, at 12 months per year, that is 60 total payments. So we're going to multiply this by 60. So we take that. Let's see. Let's clear this out. We're going to do 444.66 times 60. That means they end up paying back $26,679.60. Okay. So they borrowed 23,000. Now they have to pay back 26,000 because there's obviously interest. And it says now calculate the interest charge. So now we would simply take the 26,679.60 and subtract the 23,000 that we got as a loan to pay for these wonderful clocks. Huge money maker, I'm sure. And then we simply do the math here to say that there was $3,679 in interest. Okay? All right. right, so those are our answers for this one. Let's take a look at another one, but before we do that, let's take a quick comedy break. All right. Okay, example 2. Larry takes out a $15,000 loan over 4 years at 7.2% interest compounded monthly to buy a shoe sedan. Calculate the monthly repayments and find the outstanding balance on the loan after 1 year of repayments. So, here's the kind of the key thing here. 7.2%. We know that from our table, we only had whole number percents, and that was on a personal loan officially that it said. So we're actually not going to use that table. What we're going to want to do instead is use our Tvm Solver on our graphing calculator. Okay, so on your graphing calculator, you want to push apps, and then it's under finance. So we push enter, and then we do Tvm Solver. We push enter. All right, so we've used this a few times before, so to kind of refresh your memory, N is the number of total payments. So if we're doing 4 years at 12 payments per year, because it's always monthly, we are going to want to have 48 on here. Okay, so 48, because that is 4 times 12 is 48, right? That's the total number of months. Interest rate, we have 7.2. The present value, always want to put that in as a negative because this is like the money that you're borrowing. So it's 15,000 here. Payment is what we're going to figure out. But if you clear that out and try to go somewhere else, it makes you put something in. So you just put a number in there and we're going to solve for it here in a bit. We want the future value to end up to be 0. We want to pay this whole thing off in 48 months, 48 payments. The payments per year is 12, and the compound periods per year is also 12. Okay, so now what we want to do is we want to highlight what we want to solve for, and in this case it was payment. Remember, we just put some random number in there. So now we want to solve for that. So we highlight payment, and now we do alpha, and then if you look up above the enter, the green word up there is solve. So we're going to solve this thing. So we push alpha and then enter. So our payment is $360.59. Okay, so each month is $360.59 is our monthly payment, right? So always go up. Okay, so now it says find the outstanding balance on the loan after 1 year of repayments. This is where that table, it's not going to really work very well with this because this is the outstanding balance that they're asking for is what is owed, what officially without the interest, what is still owed on the loan. That's what I was trying to spit out. Sorry. So what we want to do is we want to go back up here to the top number of payments. If we want to find the outstanding balance on the loan after 1 year of repayments, now we've only made 12 payments because that's 1 times 12. Interest rate still 7.2. The loan amount was still 15,000. The payment, we are actually going to put in 360.59. It probably won't make a huge difference, but let's just put that in there anyway. 360.59 because we always go up to the next penny. Future value is what we're going to solve for, so we can just leave that as 0, and the payments and compound periods are still 12 each. So since we're trying to figure out what they are, what's the outstanding balance, we want to highlight FV, so then we would do alpha and solve for that, and the future value would be 11,643.60. We'll call it. We could actually round this one to the 0.59. 11,643.59 is what the outstanding balance is. So if basically went through and made payment and there was no penalty for paying off your loan early, Larry could pay the remaining $11,643.59 at the end of that 1 year and be done with his loan. Okay? Okay. That's all we have for notes on loans. If you have any further questions, please feel free to ask. Thanks.